Section 10 miscellaneous control equipment. The master control the fingers are cam operated double brake and required no attention other than it's easy. The contact clean of the no springs broken in the finger of the board are easily removed by taking off the screws. Each end of the fingerboard added the roller showed being examined occasionally to see the turning of the freely contact. The pressure is 7 ounces minimum. Each contact remove the drums, the back plate of the switch to remove the dial pin of the top plate of the rear left center. Remove the tool bolt to the rear shoulder of the top plate of the corresponding tool bolt. 2 bolts from the bottom plate. The drum will be freed and can be removed moving the forward when reassembling the drum, reinserting the dial pin, tightening the 2 bolts at the rear corner of the top plate, positioning the drums respecting the cam switch to tighten the tool bolts at the rear corners of the bottom plate. The reverser description of the reversing consists of the drum insulated with the copper segments capable of rotation through a small angle of the 2 air cylinders, piston, drum, rotation control, magnets, valves, power control, and fingers insulation pays for the care of the magnet valves. Refer to the paragraph 88. Figures of the pressure of the fingers on the contacts should be approximately 5 to 6 pounds. More main contacts 1.5 to 3 pounds of the interlocking fingers of the finger pressure that can be measured. It means the small springs balanced and attached with the piece of bent metal strap, which can be slipped under the finger. The segment under the fingers is cleaned and do not lift the fingers far enough off the drum surface so that the strain of the spring is reduced and the tension, such as common sources of the travel, should be carefully avoided. If the contact of the fingers drum segment that allowed the operator to completely dry, they will cut the comparatively short time. Spread a little bit of little light machine oil occasionally over the drum contact with a piece of cloth operating the drum a few times. Wipe off the surplus oil around the contact of the segments. Oil the drum bearings at the intervals with the light oil. The finger pressure is verified, changing the finger spring with the flap spring type of the used to increase the pressure necessary for the finger, removing the screws which are holding it into place, giving the spring a little of the greater set. The finger will maintain their pressure in a long period of the time as are not abused. The finger should be compensated type of the kind, not be adjusted in spring tension of the damaged finger that can be replaced. The cylinder piston, the piston properly oiled by the reverser assembly of the factory or ordinarily function of this long period of 6 months a year before them requires additional lubrication. When the lubrication is necessary, use only the specified figure 5. The use of the unsustainable oil will lead to the trouble from gum position, would cause sluggish sticking. Ordered to remove the piston rod. The piston necessary to the first removal of the 4 tap bolts which hold the drum. Bearings in place with lift of the drum. Next tap of the bolts. Each cylinder head should be taken off the head of the removed, being exercised not in the injured paper gaskets which are under them. Removing the nut lock washers, one of each of the piston rod, after which the piston rod, one piston attached, can be shoved out of the cylinder by pushing on the end of the piston rod with the screwdriver. The remaining piston in the cylinder easily pushed out from this other cylinder other end. It is not advisable to push off the piston opening the center of the cylinder line. Leather may be injured. The magnet valve. The sander and the engine shutdown are provided with the magnet valves in which are governed. Here is a reverser outline of the emission of the air, exhaustion of the air operated in cylinder magnet valves naturally into the 2 general classifications unoperatably, principally named standard and inverted valves. The standard valve that energizes emits the air pressure to the small port ceiling. After the air passes through the valve into the air cylinder, actuates the complete of the apparatus involved. The full throttle air reserve acts continually cylinder as long as the magnet valve coil energized while another valve in another seat prevents the air from escaping from the magnet valve's exhaust port. The inverted valve energized axis to follow shows the supply line allows the air from the cylinder through the exhaust port of the magnet valve, so sequentially switches the usually both types of valves, same type of due to the opposed direction of the travel of the piston of the air cylinder. The magnet valve being alternately energized, de-energized depending on the direction of the motion necessary. Figure 22 and 23 illustrate the general principle of the magnet valves using a typical cross section standard valve. The chief distinction between the standard inverted valves, they are standard valve, 1 bushings, 2 seats, upper, lower, and lower, and 2 valve stems are used in the inverted valve. The 2 bushings and 1 floating valve with the 2-phase actuated push rod operating the bushing as are used in the instruction. Corresponding valve parts and similar in following description therefore applies to the valves. Figure 22 and 23 show the diagrammatic cross-sectional valve and standard magnetic valve. The operating parts of the position they occupy, which there are no current passing coils under the condition of the spring pushes the valve against the seat of the seat that prevents the air passing from the control air supply supporting. The cross-sectional view of the open coil standard magnet valves is in the copper upper seat of the valve. The air form of the control reserve here the current connection pipe, the cutaway, the plug of the valve, the spring of the valve, the sheet and the lower valve, the stem, the passage valve, and the export to the coil and the magnet cap origin or armature. The cross-sectional the spring is not only the closest to the valve, but at the same time the valve is the offseat to the cleaves, the clear opening, the escape of the operating cylinder that passes the JF into the atmosphere. The magnet coil energizes the armature, pushes down on the stem, opens the valve, and admits the supply operating cylinder to the passage P. At the same time, the exhaust pipe of the maintenance procedure of all valves is particularly the same. Occasionally, the valve will blow, giving the hissing sound due to the leak which occurs. The magnet valve de-energizes the blows of the magnet. Exporting the port is exhaust port is on indicating the lower inlet valve. Not seeing the trouble is caused by the generally presence of little dirt in the valve seat. In most cases, the cure pressing down on the pinion during the top of the magnet valve, releasing it quickly several times. If the blowing persists, shuts off the apparatus. You unscrew the bolt in the bottom of the magnet carefully. Lower the plug of the straight down the spring into the lower valve. Will drop within while in the perfectly clean with a slip stick and piece of cloth and clean valve sheet. When they replace the lower spring valve nut, remove the cap of the armature so that the case of the valve stem does not properly enter the holes of the stem, freely lifted for the advancing instead of being damaged and let the exhaust valve not tight. The difficulty sometimes overcome the inserting the small screwdriver in the top of the slot and spinning it a few times on the seat. Exhaust valve leakage in the standard valve. In case of a standard valve blows, the exhaust port when the control is energized, signs of the exhaust of the valve not seating on the properly on the seat, which is due to one of the following causes, as mentioned in order the usually a liability. So you got your if an exhaust valve leak, it blows. If a standard valve blows, figure 23 is a cross-sectional open coil, the type of the coil or ordinated magnet valve. It's got the armature with the magnet type of the cap, the core, the upper valve stem, the coil, the exhaust lower valve, the passage valve, and the spring and the plug of the valve nut. Followed up to the two air cylinder valve seated in the passage seat, and the air of the control, the air supply enters in. If the standard valve blows, the usual liability occurrence of the dirty valve, a weak of the battery, low voltage power, dirty under the magnet armature. The valve stem is unsworn due to the armature strikes the cord before the valve seats. Remove the stem. If necessary, shut off the valve, shut off the air. First, remove the cap over the armature. Fill the armature with it not fastened in any way. Next, place the finger of the one hand over the magnet valve exhaust port of the F and presents down top of the valve stem with the finger over the quick hand of the raise and the finger quickly. The valve stem will be raised. The air pressure can be readily lifted off the end of the valve with a wipe clean. A weak battery sometimes gives a sufficient pull to unset the lower valve, not enough to close the exhaust. The obvious remedy of charged battery. Another possible cause of blowing exhaust valve is a worn-down stem, and very unlikely to occur after the equipment has been serviced in years. If the stem is too short, it can be slightly stretched by peening the shank. So if you have a valve that is blown, a standard valve that is blown, then it's worn down to the stem, you can peen the shank, which is later talked about. The valve gauge, in order to satisfactory operation, the electro-pneumatic valves, it is necessary to maintain the travel of the valve, the vinyl gap between the magnet armature core and the certain elements. A considerable period of the service is wearing down the necessary refit that replaces in order to accurately determine the condition. And the similar gauge is employed by the gauge used in the both standard inverted valve by turning it over and depending on the type of the valve, checking the adjusting standard of the upper valve stem. The checking gauge is used to check adjust the final gap of the length of the new upper valve. Remove the magnet valve, insert the gauge as shown in figure 25 at the file type of the upper stem until the 56,000 inch should admit the cylinder slightly leak of the exhaust pipe of the 52,000 inch gauge of this exhaust pipe. All the type of the final air gap between the two, that's approximately 54,000 inch. New stems have excessive length that should be grounded through the seat before the adjusting the gap direction of the grinding are included below. Surface is permissible to allow the upper stems to seat of the wear until the final gap is approximately 32,000 inch or 66,000 inch of the gauge is point of fail to the unseated lower valve to emit to the cylinder to the upper levels must be stretched to the peening of the new or stretching by peening or renewing stem used on your valve. Lower valve, the same gauge as used in the upper valve of the stem has been adjusted to adjust the travel the length of the lower valve of the stem using an eighth of an inch. This will probably cause the valve to unseat below due to the excessive lower stem. The upper end of the lower stem should be flat filed with the 88,000 of an inch. Will not touch the 0.70,000 of an inch. Will unseat the lower stem. The gap is approximately 86,000 of an inch. Travel the 86,000 of an inch minus 0.54,000 of an inch or 32,000 of an inch. And surface is permissible to allow lower stem to as long as the consent damming gauge of 0.66,000 of an inch makes the lower valve below with the upper stem of the new and does not travel them in reach of 12,000 inch or lower. So, repeating with the gauge, these of the blown gat, the standard gat valves that are vertical, the 25, the gauge of the proper checking and adjusting standard values. The stem must be stretched by peening or new stem used. Checking and stretching of the peening or new stem used. So, you're either putting a new stem used or in peening it or checking the adjusting of the inverted valve. Gauge is used on the check adjusting the final gap of the length and push rod. Remove the magnet valve. Insert the gauge as shown in the figure 26. Fat foot type of the push rod until the 52,000 inch discharge of the cylinder, which single leak of the exhaust of the 49,000 inch gauge. Discharge of the cylinder and the inlet valve tighten the final air gauge between the two or the approximately 50 push rod extended the length of the valve should be grounded to tight length of the before the exhaust. So basically, a peening is dropping of the gauge, the leaking out of the exhaust into approximately a fine air gap, which is the standard specifications. Directions for grinding include the same gauges used to the traveling and floating rod. It's basically floating. It's letting out the air to the cylinder air supply. The same gauges used to the track of the travel loading guide of the travel set of the factory between the 0 to 17,000 inch or 27,000 inch proper machine of the tracing floating valve and to check the travel of 79,000 inch, which closed the lower part of it should not be able to valve blow of 16,000 inch should cause the slight leak of both checks made in the cylinder charge. So you're charging the cylinder too as well. In service, impermissible allowable push rod where the final gap is approximately 32,000 of an inch. Some magnetic cores would use the clapper type of the armature used in the bronze residual stops 20,000 of an inch ill in height above the core face approximately obviously on cores using the pins of the final air gap in the setting of the 12,000 of an inch more than the height of the residual pins of 56,000 of an inch will is in this point of the fail to unseat the exhaust port discharge of the cylinder. The push rod must be stretched being peening or a new rod to use. No adjusting the floating valve. The possible flare for maximum travel exceeds the limit of approximately 12,000 of an inch. New valve must be grounded. The standard micrometer dial gauge, a more accurately method measured the valve being used. Standard the micrometer gauge special fixture shown in the figure 27. The especially convenient with a large number of the valves overhauled and the amount of material removed. The new valve determined indirectly rather than the cut off the process. The figure 27 is a micro dial gauge adjusting of the magnet valves. The grounding valve is standard use of prepared grinding compound for the purpose of making thin paste for very finely ground pumice or machine oil. Applying a little ground compound of the valves, the seating, putting the valve in place and spinning back and forth in the screwdriver until the seat is set and tight. Remove the furnace from before testing the leakage of the valve. The grinding of the lower valve, leave the upper stem to the place of the acting of the guide of the after grinding of the stems of the valve, seating thoroughly by using little gasoline and blowing out the air. Inverted valve using a compound described as 1A above the spinning valve. The grinding tool is shown in figure 29, the grounding lower seat with screwdriver for the upper seat. The cleaning push rod seats described in 1B above the valve bushings. The vertical bushing are furnished with the vertical plot holes, pilot drilled, and valve seats completely machined. 28 is a grinding standard valve. They install the bushing grinding valves outlined in the H above due to the drill horizontal of the same size original bushing installation. Magnet contactor. The magnet contactor is magnetically operated. The switch purpose of the closing opening the auxiliary power of the circuit is operated by the low voltage for the battery circuit. Each contactor has stationary and movable contacts with electromagnetic bridging of the contactor attaching together in the additional high voltage contactors, having blowout coils extinguishing the air arc of the air arc shields buried, protecting the metal portions of the switch. Stationary, moving the contacts is moving made of the harder drawn copper. The sufficient section of the longer life bearing, burning, opening, closing of the occurs only at the tip of the contacts due to the effect of this current carrying surfaces. A slight wiping action, closing, increasing the clean resistant area control area. The steel compression spring with the inserted positive contact pressure regardless of the wearing, and also cause is quick opening contacts. The arc shield barrier are made on the heat resting materials. The arc shield cannot be removed readily. Inspection of the contacts. Maintenance due to not to oil lubricating any part of the contactors to keep all the parts of accumulation. Dirt will interfere with the operation. Copper contacts normally wear to giving the best contact surface without attention. However, they not blistered contact lips to keep the heels of the contact from the closing of the smooth materials of the fine file. Do not file the heel of the contact. The contacts may burn to the heel because of the improper rolling action, moving the contact stationary contact. The meshing. This may be caused by weakening of the breaking or broken the finger spring of the should be and replaced immediately. B. The contacts will wear quickly as a result of the small travel, the very little wiping action. This may be caused by the inefficient free movement of the armature too strong of the finger spring. The renew contacts of the tips of the old contacts are worn thin when the contacts are burned at the heel. When the contact is badly worn, contacts worn until the arc damage and contacts the bolt with difficulty to remove all the damaged switches. Renew the arc shield before the heating. Assistant internal resistant material is burned away sufficient to expose the metal poles of the shield. Removed easily by taking one out of the single bolt. The flexible copper shunt tight it becomes there is dangerous shunt burning at the point. Moving the operation coil, removing the armature, disconnecting the terminal, removing the screw and nut in the coils designed to operate the contactor successfully at the form of 60% of the 110% normal voltage to stand 110% of the voltage without overheating, consistent and impregnated to make the resistant moisture oil. The keeping the sealing surface of the magnet core of the armature clean, adjusting the interlocks so that they may make contact at the correction point after the locomotive has run, and the inspection can be made of the contactor condition immediately upon the shutdown. Feeling of the temperatures on the contact interlocking hands may be adjusted with warm ones. The same one method of the inspection can be allowed for the other contacts. Determining the pull-in voltage and the overhaul is set at the pull-in at no more than 60% of the normal voltage. Faulty erratic operation may occur due to the erratic operation may occur due to high pull-in voltage or binding parts. The arcing shield that shoot of the surrounds the main contacts can be released readily, slided out position, provided that the purposes of directing the arc, preventing the coming to the contact of blowing out the pole. So the middle parts of the switch. These parts shoots are made are the arc resisting insulating material that they will gradually wear away, necessitating or occasionally renewing the size before the burns insufficiently to expose the metal pole pieces. Securely fastening the copper shunt carries the current from the moving of the top of the contactor if the broken badly worn properly. 90. Interlocking. Description. Interlocking auxiliary switch mounted in the main control electromagnetic switch. Electromagnetic contactor establishes and disconnects control circuit of the type of the operation particular switch to the therefore which completes with the control circuit with the main contacts of switch enclosed with the outer linking. Establishes the control switch of the main contacts open in a single main with the switch, and the control will be equipped in interlocks and outer interlocks of a combination bolt depending on the sequencing required. The three general types of the bolt but it's common to use of this magnet contactor slide type of the camshaft, usually on the pneumatic switches. With the butt type of this metal arm is attached with the armature of the switch. The armature actuates the pivoted insulated block on which the mounted spring supported contact switch operates the contacts bridge. The control terminals thus establishes the circuit. The sliding type of the contra holds the wires terminated and compensated fingers mounted on the base of the wedge switch, and an insulated block which carries this conductor segment is actuated. The piston arm of the switch. The switch operates the segment slides under the two fingers to complete circuit. With a cam type of the control wires are separated. The stationary spring of the mounted base of the switches bolt lock attached with the piston arm carries the small cams in which they operate. The small cases small closes the operation spring fingers and makes the brake and circuit stationary. So you have your cam, your sliding, and your magnetic. Interlocking having the important function of the performance of the apparatus. Failure to important interlock sufficient prevention over operation trouble can be avoided by periodic inspection. Inspection following the examination of the interlocking should be made in inspection period. See that the control terminals are tight. See that the interlocking contacts are clean and not worn and burned. See that there are deflection of the springs, the interlocking fingers of the bar, and when the contact is made on the butt type, this can be obtained by the adjustment of the length of the interlocking the arm. On the sliding type, this can be accomplished by putting the slight set of in the fingers. On the cap of the type of on the cam type, this is accomplished by the adjustment of the gap between fingers that should be normally 1/8 of an inch wide open. 91. The relay panel type UV56. The relay panel consists of 2 relays, 2 relay resistor tubes, and the insulating base is of 1 relay, a resistor tube on the base of the relay. Exactly one electromechanical details. The coil may be adjusted, operated different voltage. The correct operational voltage indicated in the figure 44, and each of the oil is connected with a series of one of the resistor tubes. The relay of the clapper type of device mounted on the hardened pivot bearings of the cover of the felt washer to exclude the dust and dirt. The pivot pipe points are used to minimize the friction and counterweights attached with the armature valence of moving parts, minimizing the effective vibration, moving the stationary contacts, having the contacts with silver tips. The relay is adjusted by the 2 voltage, one of the so-called pickup voltage and voltage at the coil overcomes the pole spring and the poles of the armature. The over voltage to drop out, of which the voltage is with tension of the spring overcomes the pole of the oil that pulls the armature back of the oil back away from the coil. The adjustment of the required calibrated through these relays. One of the tension springs, the second air of the gap, the relay is closed. The third air gap of the relay is open and de-energized. The adjustment have been made in the factory should not be changed. The readjustment that should have been in the soldier due to the vibration of the locomotive will not have charged. The effective pickup of the drop voltage of the 3 adjustment as follows: the increasing the tension of the spring raises both the pickup drop of the voltage, increasing the tension both the pickup and then the dropout voltage. When the relay de-energizes, the increasing the air gap between the stop of the screw stops the pickup. The voltage does not affect the dropout, decreasing the air. The gap lowers the pickup the voltage without affecting the dropout. The relay picked up with the decreasing air gap, and that means that the residual screw lowers the dropout voltage without affecting the pickup, increasing the air gap and raising the dropout voltage without affecting the pickup. And another adjustment is which may not be used to jump around the resisting tube, with this adjustment determined that the factory must not be changed. The new resistor tube is insulated. Take care of the fully assembled identification band at the lower end of the relay panel. Note that the position of the jumper on the older tube. After replacing the new tube, install the jumper on the tab corresponding on the tap on the old tube. If possible, the relay panel to the bench with the source of the variable voltage of the rain covering the pickup of the drop-out voltage. It's possible to adjust these relays of the locomotive if the circuit of the traction motor is broken, and possible adjusting them in with the locomotive operation. Maintain the pickup of the drop-out voltage figure 44, charging the proper adjustment. This only would require the infrequent intervals provided by the adjustment of the resoldering, prevented the locomotive's vibration affection, and the keep of the fingers adjustment of these wears. The fingers should be deflected by 1/6 inch when in contact with the studs, keeping the air between the fingers and the contact stud at not less than 3 2 of an inch. Should they not be floating either in or out.